So, welcome to the next lecture, which is lecture 3. In this lecture, we will be discussing on the air pollution and their types, basically gaseous and particulate air pollution. So, before I proceed, just to recall the previous lectures that we studied. In the previous lectures, we have studied how Earth's atmosphere has evolved. Okay, during this Earth history or its formation since 4 billion year ago, and it has reached to the present day stable composition. So, now we know that composition of the today's composition is nitrogen about 78%, oxygen 21%, and then less than 1% is almost argon, and then we have other trace gases and other things. They are not very much varying, but some of the species which we call as a trace gases, they are actually more important, and their composition has been varying since industrial era, you can say. And then in the same lecture we also talked about properties of the different layers of the atmosphere. So, we talked about stratosphere, lower stratosphere, and then troposphere, mesosphere, ionosphere, and what are their properties actually. So, we have done that one also. And lastly, we discussed about the radiative balance equation. Assuming that there is no atmosphere, what would have been the temperature of the Earth's surface, and we calculated the temperature, and based on that we brought the concept as well as the importance of greenhouse gases in the atmosphere. So, these few things we studied in the previous lectures. Now, let us see in the next lecture what we have. So, this is what I talked about. So, let us assume that the Earth's atmosphere was there, but there is actually no gas except the gases, there is nothing else is present, or almost you can say that there is no, or let us say that there is no atmosphere at all. So, this means there is no gas, nothing is there in the atmosphere, only we have a kind of a atmosphere, we have a solar radiation, and we have Earth surface. In between we have nothing, only thing we have, it is a kind of vacuum chamber, you can say, or it is vacuum. So, what would be the temperature of the Earth surface? It will be governed by these very equations. T effective is equals to 1 minus alpha into S0, and you divide it by 4 sigma, and you take the 1/4 root of the number that is coming out. So, it will be giving the effective temperature. Mind it, here T effective is effective temperature of the planet or the Earth surface, assuming that there is no atmosphere. Alpha, I talked that it is albedo, and we also discussed what is the albedo values of different kind of ecosystems that we have. S0, we talked about the solar constant, although it is called solar constant, but the values has been little bit varying, and we talked about the 11-year cycle little bit actually, not too much, that is a different topic altogether. Then we have sigma, which is actually Stefan Boltzmann constant. So, if you assume this equation, if you calculate the temperature, so for example, if you take S0 is equals to 342 watts per meter square, for example, and alpha you take 0.3, okay, and you calculate the temperature. So, effective temperature that will come, it would come about minus 19 degrees centigrade. This would be the temperature. Mind it, there are actually some issues also there, that if you use S0, sometimes S0 is used actually 1372 watts per meter square. In some of the literature you will see that it is actually used as 1372 watts per meter square. In this one, the factor 4, because if you take the surface area of the Earth is actually 4 pi r square. So, the 4 has been included here. If you use this equation, then you have to use 1372 watts per meter square. If you do not use 4 here in this equation, then you have to use S0 is equals to 342 watts per meter square. This is very important, otherwise your numbers will be wrong. So, be clear here that S0 is actually solar constant, and in the equation if you put 4 sigma, then the value will be 1370 or 1372 watts per meter square. But if you use the equation like 1 minus alpha into S0, sorry, it is not writing properly. So, let me write try to write this one 1 minus alpha into S0 divided by sigma, and you take 1 by 4th root of this one. So, this if you use this one, then here you have to use S0 as 342 watts per meter square. Okay. So, I hope that is clear. Now, the point is that if you see that if you see the global average temperature, say today or few years back, today the global average temperature is little bit higher, but the temperature would have is actually measured temperature is about 15 degrees centigrade or so. But if you use this equation, the temperature would have been minus 19 degrees centigrade. So, this means there is actually an imbalance of about 35 degrees centigrades between observed and predicted temperature, and we talked about that why this is a difference in the temperature, and this is where we brought the concept of greenhouse gases. Okay. So, in the greenhouse gases, how it works actually. So, as I said, in the initial stage you have a terrestrial radiation, and there is equilibrium between the incoming solar radiation and outgoing radiation from the sun. So, effectively the temperature will be calculated, you can calculate the temperature based on that. Now, when we are using more extracting and burning more fossil fuel, we are putting more of carbon dioxide in the atmosphere. Now, as you, now see what will happen if you are putting more greenhouse gases in the atmosphere. This means more radiation is actually absorbed. So, CO2 or greenhouse gases are defined as they are opaque to the incoming solar radiation. All the wavelength of radiation will come to the earth's surface, but when the earth's surface is emitting the radiation which is emitting in the IR region, they will not allow those IR radiation to go back in the atmosphere. You can assume like a wind cheater or kind of blanket that we use, or the jacket that we use in the winter season. So, in the wind cheater or the blanket, they do not allow whatever the thermal radiation of the from our body is emitting, actually it is trapped, but whatever the outside temperature is low. So, that means they do not allow low temperature to reach to our human body surface. So, this means actually these greenhouse gases are actually acting like a wind cheater or blanket. So, they are not allowing the outgoing radiation, thermal IR radiation, to go back to the atmosphere from the atmosphere. Now, what will happen? Since the more thermal IR radiation is trapped within the Earth's atmosphere, they will try to heat up, and when they try to heat up, this will lead to the increase in the temperature, and that is why it is actually called greenhouse gases. Okay. This so to sum up, if we have more greenhouse gases, this means it will help in trapping more of outgoing thermal IR radiation and will lead to a further increase in the temperature, atmospheric temperature. I hope that it is clear. If it is not clear, please do the calculations and read more basics about this one. So, the importance of greenhouse gases in the atmosphere is to trap the outgoing thermal radiation which lead to is in the increasing temperature. So, whatever the difference minus 19 and predicted temperature and 15 degrees centigrade that was there, you can see this temperature actually is balanced by the greenhouse gases. If you want to learn more about this, so this is actually a climate change science, you have to study lots of things. It is not a very simple concept. This I just gave you concept. If you want to read, Google it or take some textbook and study more of the thermal equilibrium and climate change also. So, the question that you should ask or you should study more, that what will happen if you keep on increasing in the CO2 concentration. Okay. So, this means if you keep on increasing the CO2 concentration, atmospheric temperature will be keep on increasing, and this is why most of the time we say that industrial era or because of the anthropogenic activities, the global warming is happening. Because anthropogenic activities, we burn lots of fossil fuels and like diesel, petrol, coals and other things. So, they produce huge amount of carbon dioxide in the atmosphere. So, if you have more carbon dioxide in the atmosphere, means you are putting more absorbing greenhouse gases in the atmosphere. So, they will be trapping more thermal radiation, they will lead to the increase in the temperature. Now, there is another view which most of the time this geologists talk about, that whether the carbon dioxide has increased substantially. So, when we compare, we talk about pre-industrial era, which is about 1850 years, and then from 1850 to 2024 or 25, you can see that about in 150 years, 25 years, how much increase in the CO2 concentration has been there. So, during the pre-industrial era, CO2 concentration was about 280 watts per meter square, but now we have a CO2 concentration which is actually more of 424, 25 or something like that. There is a huge increase in the carbon dioxide concentration in the atmosphere. So, this directly links with the increase in the temperature, and the increase in the temperature, the timing of the increase in the atmospheric temperature and CO2 concentration, they coincide with each other. So, the people talk about that, okay, CO2 is actually one of the main reasons for increasing in the temperature. There is another story that we should study whether CO2 is good or bad for us. Several people talk about, because CO2, if you have more CO2 in the atmosphere and if you have more plants, so plants will basically do photosynthesis, and during the photosynthesis they require carbon dioxide and water molecule and then sunlight. So, this means the photosynthesis would increase in another way. So, if photosynthesis increases, this means there will be increase in the productivity or the grains, and then whatever the plants will grow, we can grow more plants and other things. So, there is a different story altogether, but you have to stick to what you are studying and how we are doing to this one. So, CO2 is certainly a kind of very important greenhouse gas. If it was not there, the temperature of the earth's surface would have been much lower, and we would not have been having a habitable atmosphere. So, this is very important, but increasing concentration is certainly not good, and we have to limit the increase in the CO2 concentration. Okay. So, I stop here on this one, and let us see what we have on other things. So, as I said that this is the present day composition: nitrogen about 78%, oxygen about 20.9 or so, argon is about 0.9, and the remaining amount is actually trace gases. Mind it, here this is very important, that these N2, oxygen and argon, they are actually sort of stable, they are not changing a lot in the concentration. So, if you measure anywhere in the troposphere or stratosphere, anywhere the concentration of any places around the globe you measure, you will find the same atmospheric air composition for nitrogen, oxygen and argon. This is why it is called stable composition that we have. But the trace gas concentrations, they are actually varying a lot. For example, in the trace gases you have CO2, you have CH4, which are again greenhouse gases, you have carbon monoxide, carbon dioxide and methane, hydrocarbons, you have ozone. In ozone we have tropospheric ozone and stratospheric ozone. So, this composition is varying. So, although it is called minor or trace gases, they are really very important to study the present day atmospheric composition as well as climate change science, or the studying the composition of the atmosphere, or you say that how they would change the radiation and many of the photochemical reactions that is happening on the earth's surface. We will study in a later stage. And then apart from this one, gases, we have aerosol or suspended particulate matter. So, basically what do you have in the atmosphere now? So, I hope that is clear. In the atmosphere we have gases and some of the particulate matter. In the gases we have main gas, nitrogen, oxygen and argon, and then we have trace gases, which is carbon dioxide, carbon monoxide, methane, hydrocarbon, ozone, etc. And in the particulate matter, we generally call it actually suspended particulate matter or aerosol. So, these are the two things that are there, and we will talk about them, that how they are called actually air pollution. Okay. So, now there is a very important concept here that we have to bring actually. So, as I said that the present day atmospheric composition is not varying, it is almost constant. Okay. So, if you talk about some times back what was the composition, although it is very difficult to find out what was the particulate matter composition that atmosphere, it is not very easy to find out. We go back and look into some proxies. For example, for carbon dioxide concentration, we go and take ice cores, we drill that one, and Antarctica or Arctic, and we drill a core, we measure the CO2 concentration, but that is not only sufficient, you need to measure the timing as well. So, in the time also we measure, and we can go back and construct that how CO2 concentration has varies. But now the problem is that how would you know that aerosol or suspended particulate matter concentration has also varied? So, this is actually a little bit a big problem, and that is why there is, when you compare, this becomes a very important thing, although we do not have very standard concentration. Okay. So, when I say what do you mean by air pollution? So, air pollution, for example, I mean, as the word suggests, it has two words actually, air and pollution. So, air is air, which is actually kind of in a system. You can call it as a colloidal system or kind of in a system, and then pollution is actually is presence of the hazardous substances in the atmosphere in an excess amount. This is very important here. There are two criteria, they have to be hazardous and they have to be in excess amount in the air. Now, how we do define hazardous actually? So, before that let us see that how I told in the just now I told that there can be two types of air pollution, one is gaseous or particulate pollution. So, air is actually present. Okay. So, air we already have is actually kind of colloidal system. So, the system is already there. In the gases, in this atmosphere, apart from the gases that we talked about in the previous slides, there is a presence of some other gases which are hazardous and they are present in the excess amount. Two things are very important, and similarly particulate matter, gases is already there and particulate matter is added in the atmosphere. Okay. And then second terms will comes air pollutants. Now, I said that the presence of hazardous substances in the atmosphere in an excess amount is called actually air pollution, and air pollutants. So, this is actually the species or the hazardous substance that are there actually in the atmosphere. Now, every species that is present in the atmosphere cannot be called as a pollutant. For example, for CO2 we do not call as a pollutant, for methane we do not call as a pollutant. So, what are the species that we called as that can be called as pollutants? So, the species, there is another criteria that they had to adversely affect either on the human health, animal, planets, microbial lives or on the ecosystem. So, this is very important. There are three terms now we have so far. One is actually presence of hazardous material. How will you define the hazardous material? Which actually has a kind of adverse effect on the human health or animal or plants or microbial life, and then it has to be present in the excess amount. Okay, and then they have to adversely affect it. The three things are very important. Okay. Now, let us see how they come into the atmosphere. So, they mainly come result of emissions into the hazardous substances at a rate that exceed the capacity of natural process in the atmosphere to convert, deposit or dilute. See, this is another very important concept you must know. Atmosphere is, or earth itself or earth's different component, they always try to make kind of system which is sustainable. For example, I tell you an example, you got a fever, what will happen? Your body, there will be actually try to control the fever itself until and unless the fever becomes very high, you do not need to take the medicines, and that is what the doctor prescribe. Doctors say that if the fever increases more than 103 or 104, then you should take paracetamol or not. So, this means our body, like our body is also a kind of natural system. If you assume that one, our bodies, different antibodies that are present in our body, they try to fight with that bacteria or virus, whatever is there, which is causing the fever. So, there is a self-sustained mechanism, everywhere it is there. So, there is a self-sustained mechanism in Earth's atmosphere, Earth's ecosystem also has. Until and unless this temperature becomes very high, until and unless this hazardous concentration composition becomes very high, they will try to reduce it, they will try to somehow or manage, but and that is called actually carrying capacity. So, carrying capacity, that is a different topic altogether. So, we measure that what is the carrying capacity of the earth or different ecosystems. So, if the concentration or the species is emitted at a rate so that the concentration becomes too much, it cannot be actually balanced by its natural process, then it will be actually causing a kind of air pollution. Natural processes are actually like they can be either converted to some other unharmful chemicals, or they could be deposited to the from the atmosphere to the earth's surface, either via dry or wet deposition, we will discuss this later, or they can be diluted itself. Okay. So, these are the things that is happening. Now, what we do actually, or what is more important to us, that how will we study that? In the so first thing actually, you have to study that what is there in the air. So, this means you have to monitor. Okay. Then you have to not only monitor, you have to find it out whether that chemical is harmful or not. If the chemical or composition or the substance, chemical substance that is there in the atmosphere, if it is harmful, then we will talk about its air pollutant or not. Okay. So, we will see that health and welfare impact studies, there are lots of studies that is conducted in this one. Then, now this is very important. As I said, how will you say that a particular species concentration is higher or it can pose a risk? So, there are different bodies, they look into it, that at what level this concentration can be actually harmful. So, the government will decide this one, agencies will look into all those things. For example, we have CPCB, SPCB, Ministry of kind of Forest and Climate Change, they although Ministry of Environment, Forest and Climate Change, they are not directly into the regulations. Most of the things is done by CPCB or SPCB, Central Pollution or State Pollution Control Board. So, they will set the ambient air concentration standard. If the concentration is reaching or it is becoming more than that, then they will be calling as a pollutants. Okay. Then the last and very important is actually how can we lower concentration. Okay. So, this is actually kind of proposed control mechanisms on the emissions or the regulations that are there. So, four things are important. First, you have to identify that what is there in the air, how much is what kind of chemical is there. So, what is there in the air, you monitor that one, which chemicals are important among those you have monitored, then set ambient guidelines, concentration guidelines for that one, which can pose a risk for that, and then you try to do that proposed kind of control measures to this one. This is so I talked about that there are two types of pollution, one is actually either particulate air pollution or gaseous air pollution. So, one thing is always confusing to students and to us, that what is the label, because you have to compare, you have to put somewhere, you have to put a baseline, right, or benchmark above which you will call, and that is actually we call it as actually ambient air concentration or NAQAS, National Ambient Air Quality Standard guidelines are there. So, the concentration is fixed. Now, you have a fixed concentration, and because in ideally, so if I just plot this graph here, and if you see here, concentration is actually say normal or no, and if your concentration is here, if the concentration is above these levels, then you will call it as a pollutants. So, this is actually NAQS standard or any guideline that you have to have, and then concentration above that level will be called as a pollutants. Now, so I said that for gases it is some sort of easy to get some of the data. For particulate matters, they usually are not very good proxies, because particulate matter can be dissolved. CO2 for example, in the ice cores, why CO2 we can measure CO2 concentration, because CO2 concentration once it is trapped in the air in the ice sheets, it is trapped as a CO2, it is not reacting because the atmosphere become an kind of inert atmosphere and it is closed system. So, it is not reacting anymore. But when you have dust, actually for example, in aerosols we have dust, ice or fumes or carbonaceous material, some of them have the actually water soluble property. So, if they are actually there, they will be dissolved. So, if they are dissolved, then their concentration will reduce. So, getting that ambient what was the concentration at that time is not very easy. In this one, generally we take as a black carbon as a actually we measure black carbon in the snow. So, black carbon is sort of very is highly refractory. It's most of the time it is absorbing aerosols and it is water insoluble, that is more important. So, whether it is there in the atmosphere or it is in the ice sheets or in the sea ice core, black carbon will not be actually dissolved. So, you have actually kind of concentration, and if you have a timeline you can do that one. So, as I said, so two types of air pollution, particulate matter. In the particulate matter we have we generally call it is either is a particulate matter or aerosol, and in aerosols we have different categories PM 2.5, PM 10, PM 1. So, PM stands for PM particulate matter, and the suffix 2.5 or 10 they stands for the particle size. So, for example, PM 2.5 means particulate matter with aerodynamic diameter less than 2.5 micron. Okay. We will discuss this one in later slides. Okay. So, this is actually some examples of particulate solid particles, like you have dust, ash, fumes, carbonaceous materials, and then they actually like solid and liquid also, smoke from the combustion that can be called, it is also again in the carbonaceous material, and then some of the things like coastal aerosols, if you go there they are actually neither solid and sort of liquid, more liquid. So, that can be also. Then liquid you have aggregate gases like sulphate and nitrate, and for example, so now the question is that whether this water droplet can be called as an aerosol or not. Okay. So, yes, water droplet can be called, because it actually there are only two things, it has to be suspended in the atmosphere. So, it is suspended and it remains in the atmosphere for some time, it has aerodynamic diameter. So, it can be called an aerosol. And the second one is actually gaseous air pollution. So, our National Ambient Air Quality Standards, they have put only 6 gases that are actually called as air pollutants: CO, carbon monoxide, SOx, SO2 and other gases related to this one, NOx, NO, NO2, N2O, something like that. Then you have ozone, tropospheric ozone. Here the ozone is actually mostly tropospheric ozone, because the air pollution that we are discussing today is actually confined to the troposphere. So, ozone concentration we talked about here is tropospheric ozone concentration, not the atmospheric concentration. We have ammonia and CH6, C6H6, benzene is also called, and some of the things actually they are not specified as a kind of what you call air pollutants like polyaromatic hydrocarbons, but in the polyaromatic hydrocarbons some of the species like benzopyrene, they have been defined as a air pollutants. And then you have volatile organic compound, VOCs, lots of VOCs series are there, they can be harmful, but they are not defined. Okay. Okay. So, now this is again I talked about type, and so what are the sources actually. Okay. The sources can be either natural or anthropogenic, but most of the time air pollution results because of the mostly anthropogenic aerosols. So, this is very important, that most of the anthropogenic activities like vehicular emission, fossil fuel burning, or the agriculture waste burning, and then kind of industrial emissions, they are actually putting lots of pollution in the atmosphere. Natural air pollutants are rare, they are very rare except dust storm. So, for example, in the dust storms, when dust storm comes in India, actually if you see in the northern part of India during the summer period you get lots of dust storm there. Then smoke from the wildfires, although it is not very common in India, but part of this especially in the Uttaranchal and Uttarakhand, if you go during the summer spring season they call it actually, or summer, April, May, you can get the wildfires. Then methane released from the livestock, this is also, but they are not. The one is actually another very important is volcanic eruption. Volcanic eruption actually produce lots of air pollution, especially the sulfur dioxide, volatile gases, and then ashes in the atmosphere. So, now we have now fair idea about the air pollution and their sources. So, they are also categorized into two: primary air pollutants and secondary air pollutants. Primary, as the name suggests, primary means from the beginning itself. So, harmful substances that are emitted directly into the atmosphere, they are not formed, they can be removed, but they are not formed or they are not added in the atmosphere because of the secondary process. Secondary and similarly secondary air pollutants are those who are formed in the atmosphere, okay, when some of the species that are reactive species, they are emitted in the atmosphere, they react and form another species. So, that is called secondary air pollutants. So, secondary air pollutants, for example, you have example of sulphate, nitrate, ammonium, and then you have secondary organic aerosols. This is becoming very important. In primary air pollutants, you have black carbon, carbonaceous organic carbon, and then you have kind of dust aerosols. These are actually called primary aerosols. This is actually again the sources, terrestrial sources, dust storm. Natural sources for dust storm is actually unsustainable farming and grazing, erosion and desertification. They result because of that. Volcanoes can bring lots of natural aerosols, fires, clearing forest for agriculture, this can produce lots of things. So, this is actually the sources. If I talk about major air pollutants, in the particulate matter you have dust, lead and sulfuric acid. Sulfuric acid is actually, as I said, that now you can say whether the third column also says that whether it is primary or secondary. So, lead and dust, they are actually primary aerosols. Sulfuric acid is secondary because it is directly not produced in the atmosphere. Nitrogen oxide, nitrogen dioxide, this is actually primarily emitted. Sulfur dioxide is primary. Carbon oxide, carbon monoxide and carbon dioxide, this is actually primary, but mind it, carbon dioxide is not defined as the pollutant so far, because its harmful effect has not been very well established compared to carbon monoxide. You have methane, benzene, they are also primary among the hydrocarbons. Then you have tropospheric ozone, it is because in the troposphere we do not have ozone. So, it is called but this is actually air pollutants. So, this means it is not directly emitted, so it has to be secondary. Okay. Then air toxics like chlorine and other things, they are also primary. This is, we will come back to this later. In the gaseous air pollutants, I told about these are the 6 gaseous air pollutants: carbon monoxide, sulfur dioxide, nitrogen dioxide, ozone, ammonia and benzene. These are the 6 that is established, and they are actually, if you talk about the chemical reactivity, for example, ozone, it is highly reactive and it can form lots of secondary aerosols through this forming the radicals, OH radicals, and by reacting itself. Then they sometimes, some of these species are soluble in the water, for example, ambient NOx and SO2, they are soluble in the atmosphere. So, this is another problem. When we inhale lots of nitrogen dioxide, oxides of nitrogen and SO2. When these go into our lungs, they are converted to respective acids. That is actually one of the very big problem, and we will discuss that their impact in the later system. Then occupational hydrochloric acid and ammonia, CO2 and dissolution in seawater, ocean acidification. So, we also know that carbon dioxide, although it is not called a pollutant, please note it, this I am referring it again and again, this is not called actually a pollutants, but carbon dioxide can be dissolved in the ocean. So, when it is dissolved, it forms formic acid and formic acid H2CO3, sorry, not formic acid, H2CO3, carbonic acid. This carbonic acid is dissociated again, it gives H plus and HCO3 minus ions. This H plus actually gives you the acidity. So, it increases the pH, it decreases the pH or increases the H plus ion concentration. So, if you decrease pH or increase the concentration, the process of what you call reduction in the pH of the ocean is called ocean acidification. And there are some less soluble, for example, H2S and ozone. NAQS, this is important. So, this is, I said, National Ambient Air Quality Standard. This is established by the CPCB, Central Pollution Control Board. So, they put concentration, that how much concentration is actually harmful. So, for example, for carbon dioxide, and they divide into 2 zones, one is in industrial and eco-sensitive zone. For example, eco-sensitive is like more greenery, less people are there, or industries are there. So, that is actually like go to Himalaya. So, this is eco-sensitive or oceanic regions. Okay, industrial like urban areas. So, carbon monoxide in the industrial areas should be 2000 microgram per cubic meter. For eco-sensitive, they are same, and CO for 8 hours. There is another very important concept, that averaging time is also very important. So, this becomes important. I will come back to this one, that why the averaging time is important. So, 8 hour concentration should not, 8 hour average concentration should not increase 2000 microgram per cubic meter at industrial and eco-sensitive regions, and 1 hour concentration should not increase 4000 and 4000 in eco-sensitive and industrial regions, both the sides. Similarly, you have for sulfur oxides. Now, you see, this is another very important, because averaging time for CO is hours, 8 hours or 1 hour or hourly, but for sulfur dioxide the concentration is given in hourly, 24 hour or annual. Similarly, nitrogen dioxide also. Ozone is also given in 8 hour and 1 hour. Then ammonia is actually annual and 24-hour. Benzene is given annual concentration. So, this just think we will discuss in the next lecture, why they are the averaging time is very different for different species. Okay? This is very important. So, this is actually some concentration that you have to remember. They are usually asked in the interviews or like NET or examinations, like national eligibility examinations you have to give. They usually some of the objective questions that can be prepared from them. So, you have to just remember these numbers. Then you have volatile organic compounds. Their sources is actually petroleum emissions, fuel combustion, incineration and biomass burning. And they account for about 14% of all air pollution. They are huge actually, and there are series, hundred or thousand of volatile organic compounds that are there in the atmosphere. They are important factor for indoor air pollution. VOCs are not VOCs are of course studied in the outside or outdoor environment, but they are more in the indoor environment. Okay, there could be different types, aliphatic hydrocarbons, alcohols could be there, aldehyde, aromatic, halogenated could be there, polycyclic hydrocarbons can be there, then others can be chylone disulfide or others. So, there are so many of volatile organic compounds. I suggest you to read these things as well. And then there is another class that is called other air pollutants, which is actually called HAPs or hazardous air pollutants, and they are not included in the 6 criteria air pollutants that we discussed. So, CPCB or interviews you may be asked that what are the actually 6 criteria air pollutants, can you name them, what are their actually threshold values, are the NAQS standard values, why the averaging time is different. So, these are the things that you should prepare the notes and read more on this one. And this HAPs includes organic chemicals, minerals, pHs, metals, pesticides, and most of them actually are carcinogenic. So, this is very important. So, to sum up, we studied about what we studied in the previous 2 lectures, then we talked about the air pollution sources, what are the type of air pollutions, primary and secondary we talked about, and then we also talked about the different sources, what happens, their criteria pollutants, NAQS standards we talked about, and we talked about the VOCs and HAPs in the lectures. So, these are the things that are actually to conclude this lecture we will study, and then let's see you in the next lecture. Thank you.